Okay, so as you can see, electrons are moving forwards and backwards, forwards and backwards. Basically, this is AC, or alternating current. Alternating current is one type of electricity. Electricity is the push or pull of electrons. Now here in this circuit, in an AC circuit, we can see an AC source. Now this AC source could be a generator or it could be socket in your home. So this AC source is pushing those electrons and pulling them back through this resistor. Now the resistor resists the pull or push of electrons through it, so we needed energy to push or pull the electrons through that. And this is electricity. So electricity is a specific type of energy that pushes or pulls electrons or moves electrons. So let's see a graphical representation for AC. Okay, so this is a graphical representation for AC. As you can see, the voltage increases and reaches a peak point over here. Then the voltage decreases and reaches its reference line or zero, and then reaches its peak negative voltage and then reaches back to zero or reference line and then back to the peak volume. Now here in this circuit you can see that we have an AC source of 40 Hz. This means that the electrons are moving forwards and coming backwards and doing this process for 40 times in a second. Okay, so as you can see, the electrons here are moving in one direction and they don't move in the other. Now this is also electricity, but this one is DC or direct current. Now as I said before, electricity is an energy that pushes or pulls electron. Now here you can see this battery in a DC circuit which pushes those electrons through the resistors. So DC sources can be batteries or solar panels. Now as you can see, the polarity in this circuit is the electrons moving from positive side to the negative side. Now this is conventional current and we will be talking about this later. So let's change the polarity. Let's make electrons move like backwards. So we can do this by just swapping the terminals or changing the polarity of the battery. And as you can see, we now make the electrons move backwards. We changed nothing, but we changed the positive and negative side of the battery. We made the positive side being this side and the negative side being this side. So here the energy pushes the electrons and takes it back at the negative side. Let's see a graphical representation of DC. Okay, so this is a graphical representation for DC. As you can see, we have a steady voltage over here being 5 volts. Now we can check that by right clicking and clicking on edit. We can see that we have 5 volts DC. We also can change that. So let's change it to 6 or 9 volts. Okay, so as you can see, now we have a different graphical representation, the voltage being 9 volts and the current being 9 milliamps. Now the reason for the current being 9 milliamps is that we have a 1 kilo ohm resistor, and this is Ohm's law, which we will be talking about later. So in DC or direct current, we have a stable voltage and stable current. But this is not true, or this is not practically true, because over time we lose energy. The battery loses energy, so the voltage line becomes like a curve which decreases very slowly over time. But this happens in long amount of times, usually being 1 or 2 or 3 years or more depending on the battery. Okay, so that's it for this video. Thanks for watching. Don't forget to subscribe and click on the videos over here to stay with us.